So how do you actually figure out the angle that you're actually supposed to rotate a conic equation? And then how do you do it so you can figure out all that key stuff? Well, here's kind of the easiest rotated conic I could come up with. If you notice, if you add 1 to both sides and then divide by x, you actually end up with what? Y equals 1 over x. You've probably seen that graph a few dozen times before. You can actually see that's a hyperbola, right? And so you want to start with something you have intuition for. How do we figure out how far to rotate it? Well, the answer is you want to start with the what? A minus C under B formula. I think of it as ABC, right? So the A is the x squared coefficient, that's 0. The C is the y squared coefficient, that's 0. And then this is the B. Notice that this is undefined. Now, normally what we have is we have this equal to tan of 2 theta, okay? And we shouldn't worry too much about that being undefined because remember, the way we came up with this equation was actually dividing. And so we should just look at where this would be undefined. Well, where's tangent undefined? Where 2 theta is equal to 90 degrees. So theta equals 45 degrees. When it's simple enough, you can have a picture, you could sort of guess, oh yeah, we're going to rotate by 45 degrees. So what does the rotation equation look like there? Well, x equals, right, cosine of 45 degrees, root 2 over 2, x prime, minus sine of 45 degrees, root 2 over 2, y prime, y equals sine, root 2 over 2 of 45 degrees again, x prime plus cosine, root 2 over 2, y prime. Now we're going to take these and we're going to actually stick them into that equation, right? So I'll go ahead and work those two rather than writing it all the way out, but it's this thing times that thing. So first times first, root 2 over 2 times root 2 over 2, that's 1/2 x prime squared. Then what happens with the middle term? Well, I get this times that, that's 1/2 x prime y prime. Maybe I'll even write it out once. 1/2 x prime y prime. This gives you negative 1/2 x prime y prime. And that's a really good thing because the whole point of this was to eliminate the b term. That's what gets us axes that are vertical or horizontal. Eliminate that b term. The last term that we have is minus, this times this is again 1/2, very creative, y prime squared, minus 1 equals 0. So then let's see, we add 1 to both sides, and you could write it as x prime squared over, if you really wanted it in sort of the formal form, 1/2 over root 2 squared. 1/2 is 1 over root 2 squared. So A is going to be root 2, B is going to be root 2, and you see you have the classic sort of equation for a parabola. You could graph that. Notice I've just taken the liberty of graphing it. It's pretty much the standard thing, but if you put in the other axes, then you can begin to find things like the focus over here that would be really critical, or the focus on this side, or where, you know, the transverse and the conjugate axes are, right? And this one happens to be centered at the origin, but that works for other things too. And I have another example here. This one's just a little area, right? Okay, first off, again, we've got negative 2 root 3 over a minus b, so that's negative 2. So what angle has a slope of root 3? Well, you probably remember that's sort of the 60-degree angle. So 2 theta is 60, which means theta equals 30 degrees. So I'll take the limit of just sort of motoring through. Cosine of 30, right? What is that? That's root 3 over 2 x prime minus sine 1/2 y prime. Y is 1/2, that's sine of 30 x prime plus cosine root 3 over 2 y prime. Now I'm going to stick those into this, right? That's going to be a pretty hairy piece of arithmetic. So 6, and then you've got this root 3 over 2 x prime minus 1/2 y prime squared minus 2 root 3 over 2 x prime minus 1/2 y prime 1/2 x prime plus root 3 over 2 y prime. And you're going to have a bunch of terms here, right? All the way out to equals 0. Now I've taken the liberty of sort of pre-processing that for you, okay? So think about it. If you multiplied all of this out in the first term, right, you'd have root 3 over 2 squared, so that's 3/4 times 6 is 9/2 x prime squared. So this term here is going to come right here. It's going to have an x prime squared term, an x prime y prime term, and a y prime squared term. Now, you're going to do the same thing right here, okay? You're going to also get an x prime squared, an x prime y prime, and a y prime squared. So I'm going to go ahead and take that, and I'm going to write it down here because eventually you're going to be gathering all of these things in columns anyway, right? So hopefully that makes sense. The third term here, right, is going to go there. Now notice the linear terms up here, the terms that just have 1, aren't going to come up with x prime squareds. So we've got negative 10 times y and negative 10 root 3 times x. This term here, I went ahead and you could check my arithmetic there. This term here, I put there. And now what we have to do is we have to sort of gather all of those terms, okay? So let's sort of think about that. What happens here if you gather 9/2 minus 3/2, that's 6/2, or 3, so we get 5x prime squared, right? Minus 3 root 3 minus root 3 plus 4 root 3. Phew. If those don't cancel, we didn't rotate right or we made an algebra mistake. 3/2 plus 3/2 is 3, plus 6 is 9, so we have plus 9 y prime squared. This comes out to negative 20 x prime. These cancel. Now those aren't guaranteed to cancel. This is just a particularly nice example. Okay, so what do you have here? Well, this right here is a shift. There's no guarantee that it's at the origin, and I made this one a little centered off the origin. So you'd have to do a little completing the squares action here, right? 4x prime plus blank 9 y prime squared, move the 25 over to the other side. So what is this? Well, divide this by 2. So negative 2 squared is 4 times, so this is going to be 4, which means I really added 20 to the left side. So I've got to add 20 here. So this is a perfect square. X prime minus 2 squared plus 9 y prime squared equals 45. Divide by 45 so that you can get it in the classic ellipse form. So this is x prime minus 2 squared. You can have a 9 in the denominator, so let's just write that as 3 squared. Dividing this by 45, you have a 5 in the denominator. I typically write that as the square root of 5 squared. So a is 3, b is root 5. And this is what the picture would look like. This is the original shape if you'd have just graphed that equation that you started with. But when you put in those axes, you can see this is what I'm really looking at, right? With those axes rotated 30 degrees. And so, in fact, that in the new coordinate system, you can see, okay, what happened was my center was shifted right 2, right? And you can see that in that coordinate system, this distance is 3, that distance is root 5, you can find the foci, everything works great.